In this screencast, we are going to talk about some common reaction types. The first one we're going to talk about is a combination reaction. Sometimes it's also called a synthesis reaction, so watch out. Those are used pretty interchangeably. And in this reaction, this is just the joining of two or more elements or compounds to produce a product. So let's look at an example of that. Um, if you look at this image, I love this image for a lot of different reasons. One of those reasons is that we can see what's happening here, right? When we do this reaction, we can see what happens on the molecular level here, and then we can see this reaction here. This is an example of a combination reaction. This is magnesium metal. It's a magnesium ribbon here. And you can see how it says magnesium solid here, and you can see the magnesium metal atoms here. We can react with O2. I want you to notice that O2 is one of those diatomic elements. So we have a molecule of O2 here, and we've got the oxygen here, right? And oxygen is in the air. And so when these two react, and generally you start this reaction by catching it on fire, by lighting a flame. So when these two react, it burns and it produces an intense flame. And then magnesium oxide is produced, and that's that white piece here. And you can see the magnesium oxide here where the oxygen and magnesium are there in a lattice. This is what you would see in a sparkler reaction. When we are looking to identify combustion or synthesis reactions, what you're going to do, so if we look at this example, we've got calcium solid plus Cl2 gas goes to calcium chloride gas. You are going to have two or more reactants here going to one product. So two things here, they're going to be separated by that plus, going to one product. This would be another example. So these are, I want to show you one with molecules. We've got two different things, and they react to combine into one product, and that's why it's called a combination reaction there. So that's the first reaction that we're looking at. The next reaction is the opposite of this. It's a decomposition reaction. In a decomposition reaction, you produce two or more products from a single reactant. When you look at an airbag inflates through a decomposition reaction. We have sodium nitride here, right? And it is a solid. And upon impact, it forms sodium metal and nitrogen gas. And that nitrogen gas is what inflates the airbag. Now, this is a decomposition reaction. You have one reactant and you've got two products here. So it is decomposed into two different things here. Let's look at another example. Another good example is calcium carbonate. Calcium carbonate, when you heat it, remember the triangle stands for heat, it'll form calcium oxide and carbon dioxide gas. And so again, we have one reactant and we have two or more products, and that's a decomposition reaction. The next reaction type is a single replacement reaction. This is also known as a single displacement reaction. When we talk about this reaction, I like to think of it like a dance. And so what happens is you have a single element And then you have some sort of binary compound. Now, binary just means two, so this would be an ionic or covalent molecule. And one of the elements replaces the other element. So in this example, whatever A is replacing B. It's sort of like if there was a dance, right, and somebody cut in. Here's B, right, and B leaves, and A now gets to dance, right? So that's the analogy there. When you do this, it's important to recognize that a metal or cation in the case of ammonium will replace a metal, right, or that cation, right? You don't want two metals together because those both have a positive charge. That doesn't make sense. So if we look at an example of this, you would have zinc solid plus copper sulfate going to zinc sulfate and copper solid. And so what you have here, when we look at this, right, there's our zinc, and now the zinc is here complexed with a sulfate. The copper was here. I'm going to change that color just a little bit. Let's change it to purple. Okay, the copper was here, and now the copper is all by itself. Okay, you will sometimes see this with nonmetals, right? And so just like with metals, nonmetals or anions will replace the other nonmetal or anion. And so that's what we'll see during that replacement there. Now, our next reaction type is a double displacement reaction. It's also known as a double replacement reaction. And this is more like a square dance, where the two metals or the two cations are going to switch, okay? So when we look at this, so the metals or cations will replace the metal or cation. So when we look at an example of this, for example, if you have barium chloride, which is aqueous, plus potassium sulfate, which is aqueous, that goes to barium sulfate, which is a solid, and potassium chloride, which is aqueous. And I just want it to be balanced. And what you'll notice here, right, is if we look at our barium is here with the chlorine, right? And now we've got the barium and the chlorine, and they're no longer together. And then we have potassium sulfate here, and now the potassium is with the chlorine, and then the barium now is with the sulfate. So what's happened is the barium here, right, has just changed places with that potassium. Okay, and so that's how we recognize it as a double displacement reaction. Another reaction that we run into is a combustion reaction. Combustion reactions are just what happens when you have a hydrocarbon and it burns to produce CO2 and H2O. We run into these in things like Bunsen burners, or butane lighters is another good example. So you'll see combustion reactions quite frequently. When we look at a combustion reaction, this is a combustion reaction. We can recognize it because we have a hydrocarbon here. It's an element made of just carbon and hydrogen. It reacts with oxygen and produces carbon dioxide and water. Every time we'll react with oxygen and produce carbon dioxide and water. And you can see this here. This would be like methane gas burning. This is not balanced. We're going to spend just a little bit of time working on balancing combustion reactions. They're just a little more difficult sometimes, and I wanted us to get a little bit more practice in. So when we look at this combustion reaction and we get set up to balance it, we are going to kind of look at the number of atoms on both sides. So this would be a time where if you wanted to practice this and restart the screencast, that would be really great practice because then you could double check your work. So on this side, we have 1 carbon. We also have 1 carbon on this side. We have 4 hydrogens here. And then we have 2 hydrogens here. We have 2 oxygens here. And then the oxygens here are 3. We always start looking at carbon first because we want to leave hydrogen and oxygen till last. So our carbons are balanced. We don't really have to mess with those. The next one that I would go to would be hydrogen. The reason I would go to hydrogen is because when we look at oxygen, oxygen is here and here, right? So hydrogen is just in one element here and one element here, or sorry, one compound here and one compound here. So we come over here and I say, okay, I'd go to the side with the fewer hydrogens because that means that's the side that I'm going to need to use a coefficient at. And I say, okay, how can I make this coefficient, this number of hydrogens too, what coefficient can I choose that would make this a 4? And so we come here and we're going to put a 2 here. When we do that, that makes those hydrogens 4. Now that also changes our oxygen. And so when we look at how the oxygen is changed, we end up with 4 oxygens. We have 2 times an oxygen here, that gives us 2, and then 2 other oxygens here. We add those together, and that's where we come up with 4. So now we've got 4 here and 2 here. We come to the side with the fewer number of oxygen atoms because that's the side that we need to use the coefficient at. And so if we put a 2 here, now we have 4 oxygens, and that's balanced. The reason I wanted to practice combustion reactions is because sometimes they can get a little overwhelming because some of them will use really large coefficients. And so sometimes that can be scary if you haven't balanced before or it's been a really long time. So we'll practice one more, and then I'm going to talk to you about a trick that you can use as well. So we've got C3H8 plus O2. It's going to carbon dioxide and water. It's a hydrocarbon reacting with oxygen. That's how we know that it's combustion reaction. When we look at this and we say, okay, we've got 3 carbons here and we have 1 carbon here. Hydrogens are next. We have 8 hydrogens here. We've got 2 hydrogens here. Oxygens, we've got 2. Oxygens here, we have 3. So now we're going to come in and we need to balance our carbons first. So our carbons aren't automatically balanced. So I'm going to put a 3 right here. When I do that, that will balance my carbons, but now my oxygen numbers are a little different. So I come over here, I say, okay, this is 3 times 2, that gives me 6 plus 1, right? So now I have 7 oxygens. I'm going to wait on oxygen to the very last because it's in two different elements on one side. And I'm going to tackle hydrogen next. So there are 8 here and only 2 here. That means I need to put a coefficient here to increase that number. So I come here and I say, great, 4 times 2, that gives me 8 here. Those are now balanced. But now I've messed with my oxygens, so I need to recount again. So 3 times 2 is 6 plus 4. That gives me 10. Okay. And so now to balance my oxygens, I take 5, and 5 times 2 is 10. And so this is balanced. Now, I want you to notice the last two examples that we've done, the number of carbons have been odd, okay? Even number of carbons, if you have an even number of carbons in a combustion reaction, sometimes that can just be a little bit more challenging to balance. So if you end up with an even number of carbons in the hydrocarbon of a combustion reaction, it is easier to balance if you double the hydrocarbon first. So what do I mean by that? So if we look at this example, we've got C4H10 plus O2 goes to CO2 and water. That there are 4 hydrocarbons. That is an even number. I want to double this hydrocarbon right here out of the gate. It just will make your balancing easier. So if you have an even number of carbons in your hydrocarbon, just double it. So now I'm going to figure out how many atoms I have on each side. When I look at carbon, I have 8 carbons here. When I look at hydrogen, I've got 2 times 10, that's 20. And when I look at oxygen, there are 2. I'm going to come over here. I've got 1 carbon. I've got 2 hydrogens. And I have 3 oxygens. The first thing I'm going to do is balance my carbons. So I have 8 on one side. I'm going to come over here and put an 8. I'm going to look at what that does to my oxygens. 8 times 2 is 16, plus 1 is 17. So that makes that 17, and these 8. Now I'm going to balance my hydrogens. I have 20 hydrogens here and 2 here. The way that I can balance that is to put a 10 here. 10 times 2 gives me 20. So now those are balanced. But again, I've messed with my oxygens. So 8 times 2 is 16 plus 10. That gives me 26 oxygens on that side. So now to balance my oxygens, I have to come over here and do a 13 in front of the O2, and that will give me 26. Some things to check here. You need to make sure that when you have these numbers like this, that you can't divide all of the numbers by something to get lower coefficients. So what do I mean by that? You can't divide everything by 2 here and get a smaller number. You always want the coefficients to be in the smallest possible number. But we can't do that because this is 13, and if we did that, we would not have a whole number anymore. Okay? So I wanted to spend a little bit more time practicing the combustion reactions, and then I want to talk about the last type of reaction, which is a precipitation reaction. And when we talk about a precipitation reaction, right, it is a reaction that generally is a double displacement reaction, and it forms some sort of solid from aqueous solutions. So if you have silver nitrate and sodium chloride and they mix together, they form sodium nitrate and silver chloride. That's a solid. That solid is the precipitate. So when we talk about a precipitate or something that precipitates out, right? That is what we're talking about. We're talking about something that is solid. So one of the things I want to point out here is double displacement reactions can be classified as a double displacement, but they can also be classified as a precipitation reaction as well. But basically a precipitate is just something that's solid. And a lot of times we refer to that as falling out of the solution, even though what's really happening is there's a chemical reaction going on where a solid has formed. So that's the last reaction we're going to talk about in this screencast. We do have 2 additional reaction types that we're going to talk about. We're going to talk about oxidation and reduction reactions and acid-base reactions, but those are a little more intricate, and so they get their own screencast.